What if I told you that one of the most important scientific discoveries in human history may have started with something as ordinary as an apple? Not a spaceship, not a giant laboratory, not a billion-dollar experiment. Just an apple. For centuries, people watched objects fall to the ground every single day. Apples fell, leaves fell, rain fell. Nobody thought much about it. But one day, a simple question changed everything. Why do things always fall down? That question eventually led to a discovery that helped humans understand the motion of planets, predict eclipses, launch satellites, send astronauts into space, and even build the technology that guides your smartphone today. And it all traces back to a curious thinker named Isaac Newton. But here's the surprising part. The apple itself wasn't the real discovery. The question behind the apple was. So how did a falling fruit help unlock the secrets of the universe? Let's find out.
Imagine living in the 1600s. At that time, people knew that objects fell to Earth. That wasn't a mystery. The real mystery was something much bigger. Why does the moon stay in the sky? Think about it. If everything falls downward, why doesn't the moon fall onto Earth? And why do planets keep moving around the sun instead of flying away into space? Scientists had observations. They had ideas, but nobody had a complete explanation. The universe seemed to follow invisible rules, but nobody knew exactly what those rules were. Then came Isaac Newton. According to historical accounts, Newton was sitting near an apple tree when he observed an apple fall. Whether it landed directly on his head or not is probably a myth, but what matters is the question that followed. Instead of simply watching the apple fall, Newton wondered, what is pulling it down? And then he asked an even more powerful question. If Earth can pull an apple, could it also pull the moon? That single idea would change science forever.
This in a simple way. Imagine you tie a ball to a string and start swinging it around your head. Why doesn't the ball fly off in a straight line? Because the string keeps pulling it inward. Without the string, the ball would shoot away. Newton imagined something similar happening in space. What if Earth was constantly pulling on the moon? The moon wants to move in a straight line, but Earth's pull keeps bending its path. As a result, the moon keeps circling Earth. It's actually falling all the time, but it keeps missing Earth because it's moving sideways so fast. This was a revolutionary idea. The same force that pulls an apple downward could also control the motion of the moon. In other words, the heavens and the Earth might follow the exact same rules. Today, that sounds obvious. Back then, it was a radical concept. Many people believed that the sky operated under different laws than objects on Earth. Newton suggested that one universal force governed everything. That force became known as gravity.
So, what exactly is gravity? In simple terms, gravity is an attraction between objects that have mass. Anything with mass pulls on other things. You pull on Earth, Earth pulls on you. The reason you don't notice your own pull is because Earth is enormously larger than you are. Think of gravity like a giant, invisible friendship between masses. The bigger the object, the stronger the attraction. Earth is massive, so its pull is strong enough to keep oceans, mountains, animals, and people attached to its surface. Without gravity, everything would float away. Cars, buildings, trees, even the air we breathe. Gravity is the reason our world stays together. But Newton didn't stop there. He wanted to describe gravity mathematically. And that's where things became truly extraordinary.
Newton developed what became known as the Law of Universal Gravitation. The word universal was important. It meant gravity wasn't just an Earth phenomenon. It existed everywhere. Newton's equations could explain why apples fall, but they could also explain the movement of the moon, the paths of planets, the behavior of comets, even the tides in Earth's oceans. For the first time in history, one set of rules explained both everyday events and cosmic events. And the predictions worked, again and again. Scientists could calculate where planets would be years into the future. They could predict eclipses. They could understand why objects moved the way they did. This was powerful evidence that Newton's ideas were correct. Imagine discovering a single key that unlocks thousands of different doors. That's what gravity became for science. The more scientists tested Newton's theory, the more accurate it appeared. For over 200 years, it became one of the most successful scientific ideas ever created.
But gravity revealed something even more astonishing. Everything in the universe is connected. Right now, every object around you is pulling on every other object. Your chair pulls on you. You pull on your desk. Your desk pulls on the floor. The floor pulls on the building. The building pulls on Earth. The forces are usually tiny, but they're there. The entire universe is filled with invisible gravitational relationships. It's like an enormous cosmic web connecting everything together. And gravity doesn't stop at Earth. It shapes stars. It forms planets. It creates galaxies. It controls the motion of entire solar systems. Without gravity, the universe would look completely different. Stars might never form. Planets might never exist. Life as we know it might never appear. A force discovered through a falling apple turned out to be one of the architects of the cosmos.
Now, here's where the story gets even more interesting. Newton's theory was incredibly successful, but science never stops asking questions. In the early 1900s, scientists noticed small details that Newton's equations couldn't fully explain. For most situations, Newton was remarkably accurate, but under extreme conditions, tiny errors appeared. Then a young physicist named Albert Einstein proposed a new way of thinking. Einstein suggested that gravity wasn't simply a force pulling objects together. Instead, massive objects bend space and time itself. Imagine placing a heavy bowling ball on a stretched rubber sheet. The sheet curves. Now place a marble nearby. The marble rolls toward the bowling ball because the surface is curved. Einstein believed something similar happens in the universe. Earth, the sun, and other massive objects curve the fabric of space-time. Objects move along those curves. This became Einstein's general theory of relativity, and once again, experiments confirmed the predictions. But here's the amazing part. Einstein didn't replace Newton. He built upon Newton's foundation. For everyday situations, Newton's equations still work extremely well. Engineers still use them regularly. So the apple's legacy remained alive.
You might be wondering, why should I care about gravity today? The answer is simple. Because gravity affects your life constantly. Every step you take depends on gravity. Every drop of rain that falls depends on gravity. Every airplane flight accounts for gravity. Every satellite orbiting Earth depends on gravity. Even GPS navigation relies on extremely accurate calculations involving gravitational effects. When you use maps on your phone, gravity is part of the reason the system works correctly. Space agencies use gravity to send spacecraft across the solar system. Sometimes they even perform gravity assists. A spacecraft flies near a planet and uses its gravitational pull like a giant slingshot to gain speed. This technique has helped missions travel billions of kilometers through space. Gravity also influences weather, ocean tides, and the structure of our planet. In other words, understanding gravity isn't just about science textbooks. It's about understanding the world around us and beyond us. The most important lesson from the apple story isn't actually about apples. It's about curiosity. Millions of people had seen objects fall before Newton. The difference was that Newton asked a deeper question. He looked at an ordinary event and saw an extraordinary mystery. That's often how science works. Breakthroughs don't always begin with expensive equipment.
sometimes they begin with simple observations: a falling apple, a moving shadow, a strange light in the sky, a question nobody thought to ask. Science advances when curiosity meets careful thinking. The apple reminds us that even the most ordinary moments can hide extraordinary truths.
Today, when you see an apple fall from a tree, it might seem completely ordinary. But hidden inside that simple event is one of humanity's greatest discoveries. A discovery that helped explain the motion of planets. A discovery that opened the door to modern physics. A discovery that helped humanity reach space. One falling apple inspired questions that transformed our understanding of the universe. And perhaps that's the greatest scientific lesson of all. The universe is full of mysteries. Sometimes the answers are hidden in distant galaxies, and sometimes they're hanging quietly from a tree branch, waiting for someone curious enough to ask, why? If a simple apple could change science forever, imagine what questions still remain unanswered today.